Welcome back to Dr. Liu's VCE Chemistry channel. Today, we are breaking down organic compounds from the 2025 NHT Chemistry exam. As I go through this, please feel free to correct any mistakes you find. All feedback from teachers, parents, and students is greatly appreciated. A. The carbon-carbon triple bond is the strongest type of triple bond. False. While the CC triple bond is very strong, approximate 839 kilojoules per mole, it is not the strongest. For example, the nitrogen triple bond is significantly stronger, at about 945 kilojoules per mole, due to the high electronegativity and small atomic radius of nitrogen. B. False. Bond energy depends on the atom carbon is bonding within the bond order, single, double, or triple. For instance, a CH bond has a different energy than a CO bond, or CC double bond. C. Bonds using carbon valence electrons have the same bond energy for all bonds. Carbon is the only element in the periodic table with a valence electron number of 4. False. Carbon is the head of group 14. All elements in this group, including silicon Si, germanium, Ge, tin, Sn, and lead, Pb, possess 4 valence electrons. D. Tetrafluoromethane, CF4, has stronger covalent bonds than tetrachloromethane, CCl4. Correct. This is due to the atomic radius and electronegativity of the halogen atoms. Fluorine is much smaller than chlorine. The CF bond is shorter than the CCl bond. In general, shorter bonds are stronger because the shared electrons are closer to the nuclei of both atoms, resulting in a stronger electrostatic attraction. To answer question 13, we look for the structure that matches the name 2,5-dimethylhept-3-ene by breaking it into 3 parts. 1. Identify the parent chain. Hept- means the longest carbon chain must have 7 carbons. -3-ene means the double bond starts at the third carbon point 2. Locate the branches 2,5-dimethyl means there are methyl groups attached to carbon 2 and carbon 5.3. Option A is the correct structure. Why it works. Chain length. Counting from the right, the chain has 7 carbons. Double bond. The double bond is between C3 and C4. Substituents. Methyl groups are correctly placed on C2 and C5. The IUPAC name for the molecule shown is B2,5-dimethylhexane-3-ol. Step-by-step naming. Identify the longest chain. The longest continuous carbon chain containing the OH group has 6 carbons, making the parent name hexane. Number the chain. Number from the side that gives the alcohol, OH, the lowest possible number. From left to right, the OH is on carbon 4. From right to left, the OH is on carbon 3. Identify substituents. There are 2 methyl groups attached to the main chain. Following the right to left numbering, these are located on carbon 2 and carbon 5. Combine 2,5-dimethyl plus hexane plus 3-ol equals 2,5-dimethylhexane-3-ol. The correct answer is C, 3-methylbutane-2-ol. A secondary alcohol is one where the carbon atom bonded to the OH group is itself bonded to 2 other carbon atoms. A. Pentan-1-ol. This is a primary alcohol because the OH is at the end of the chain. B. Pentan-5-ol. This is the same as pentan-1-ol, primary, just numbered from the wrong end. C. 3-methylbutane-2-ol. The OH is on C2. C2 is bonded to C1 and C3. Since it is bonded to 2 carbons, it is secondary. D. 2-methylbutane-2-ol. The OH is on C2, but C2 also has a methyl branch. This carbon is bonded to 3 other carbons, C1, C3, and the methyl group, making it a tertiary alcohol. The correct answer is C, iodine. Addition reaction. Ethene is an alkene containing a carbon-carbon double bond. These molecules undergo addition reactions, where the double bond opens up to bond with new atoms. Halogenation. Iodine reacts with ethene to form 1,2-diiodethane. Others, ethane, alkane, does not undergo addition. Oxygen typically causes combustion, and glycerol is a complex triol that does not add across a double bond in a standard 1:1 ratio. The correct answer is B. Why B is correct? During the reaction, the water molecule attacks the carbon, and the bond between the carbon and the halogen breaks. The departing halogen ion eventually associates with a proton released by the water molecule to form HCl. Why D is incorrect? While KOH is a very common reagent for this conversion, providing a stronger nucleophile, hydroxide ions, it is consumed in the process, making it a reactant, not a product. Correct answer, C, 2-methylpropan-2-ol. The clue: the solution remained orange, meaning the alcohol was not oxidized by the acidified potassium dichromate. The chemistry: only tertiary alcohols are resistant to oxidation by dichromate. The filter: 2-methylpropan-2-ol, C, is a tertiary alcohol with exactly 4 carbons, matching the formula. 2-methylbutane-2-ol, A, is also tertiary, but its formula is, so it doesn't fit. 3-methylbutane-2-ol, B, and butane-2-ol, D, are secondary alcohols and would have turned the solution green. To answer question 19, the core link is between efficiency and byproducts. The winning match: prevention of waste. B. Definition: high atom economy ensures that the maximum number of reactant atoms end up in the final desired product. The logic: if atoms are not in the product, they must be in the byproducts. Therefore, designing for high atom economy is the mathematical way to achieve the prevention of waste. Why others are secondary? Catalysis: A improves the rate and energy efficiency, but doesn't change the ratio of reactant mass to product mass in a balanced equation. Design for degradation: C focuses on how a product breaks down after use, not how efficiently it was made. Renewable feedstocks: D focuses on the source of materials, e.g., plants versus oil, rather than the efficiency of the chemical transformation. Correct answer, A, 6.69 g. Since the amounts of 2 reactants are known, we must determine which reactant is limited. To find the mass of paracetamol collected, we follow these steps. Identify the limiting reactant. The reaction ratio is 1:1. Since we have 0.0730 moles of 4-aminophenol and 0.0750 moles of acetic anhydride, 4-aminophenol is the limiting reactant. Calculate theoretical yield. Theoretical moles of paracetamol equals 0.0730 mol. Theoretical mass equals 0.0730 times 151 is equal to 11.023 g. Apply percentage yield. Actual mass collected equals theoretical mass times percent yield. Actual mass equals 11.023 times 0.607 is equal to 6.69 g. A. Correct sustainability is about creating value from what was previously considered trashed. B. Incorrect. While enzymes are great, many synthetic catalysts, like platinum or palladium, are also green, because they are reusable and reduce energy consumption. C. Incorrect. This is the opposite of the design for degradation principle. Safer chemicals should be designed to break down, degrade into harmless substances, not resist breaking down. D. Incorrect. Fossil fuels are non-renewable, plant-based solvents are preferred because they can be replenished. Both questions 19 and 21 are absolutely cut from the same cloth. While question 19 focuses on the mathematical efficiency of the reactions are non-renewable, plant-based solvents are preferred because they can be replenished. Both questions 19 and 21 are absolutely cut from the same cloth. While question 19 focuses on the mathematical efficiency of the reaction, atom economy, question 21 looks at the broader application of those sustainable goals, sustainability, and waste, just as atom economy aims for the prevention of waste. Q19, using industrial waste as a feedstock, Q21, fulfills the goal of a circular economy. The design aspect, in question 19, you design for atom efficiency. In question 21, you see why statement C is a trap. Designing safer chemicals actually means they should break down, degrade, rather than persist in the environment. The correct answer is D, bromine water, sodium hydrogen carbonate. Carbon-carbon double bond. The standard test for unsaturation is bromine water. When added to a compound with a double bond, the reddish-brown bromine water is decolorized as an addition reaction occurs. Carboxyl functional group. Carboxylic acids react with carbonates or hydrogen carbonates, like sodium hydrogen carbonate, to produce carbon dioxide gas. This reaction is visible as immediate effervescence, bubbles. Structural isomers, constitutional isomers. These are molecules that have the same molecular formula, but different connectivity. The atoms are bonded together in a different order. There are three main types of structural isomers. Chain isomers. The carbon skeleton is branched differently, e.g., butane versus methylpropane. Functional group isomers. The atoms are rearranged to form different functional groups, e.g., ethanol versus methoxymethane. Positional isomers. The functional group is the same, but it's attached to a different carbon. In your exercise, you were asked for structural isomers of propan-1-ol. Propan-1-ol, the OH group is on the first carbon. Propan-2-ol, the OH group is on the second carbon. Therefore, the answer to this question is 1. Compound L is propanoic acid. When propan-1-ol, a primary alcohol, reacts with acidified dichromate under heat, it is oxidized first to an aldehyde and then to a carboxylic acid. Compound N is butyl propanoate, an ester. Compound L, propanoic acid, reacts with compound M, butan-1-ol, to produce the ester shown in the pathway. Skeletal structure. Draw a 3-carbon chain, propanoate part, connected via an oxygen to a 4-carbon chain, butyl part. This is a condensation reaction, where the OH from the acid and the H from the alcohol's hydroxy group combine to spit out a water molecule. Concentrated sulfuric acid is used to increase the rate of reaction. Here, the concentrated is a key word because diluted sulfuric acid cannot work. IUPAC name for compound N is butyl propanoate. Butyl comes from the alcohol, butan-1-ol. Propanoate comes from the carboxylic acid, propanoic acid. Compound N undergoes hydrolysis with water to reform the acid and alcohol. Compound P reacts with acidified potassium permanganate, meaning P is the alcohol component. IUPAC name, butan-1-ol. Atom economy is a measure of how much of the starting materials end up in the final desired product rather than as waste. It is a key principle of green chemistry used to evaluate the efficiency of a chemical reaction. Atom economy measures what percentage of the total mass of reactants ends up in the useful product. Reactants mass, 130, compound N, plus 18, water, equals 148 g a mole. Desired product, butane 1-ol, compound P, equals 74 grams per mole. Atom economy, 74, 148, times 100% equals 50.0%. Compound Q, propanoic acid, will have a higher boiling point than P, butane 1-ol. While both can form hydrogen bonds, carboxylic acids form stable dimers, resulting in stronger intermolecular forces than those in alcohols. 1. Physical and chemical properties. Bond strength. Stronger bonds result from smaller atomic radii and higher electronegativity. For example, CF is stronger than CCl because the shorter bond length allows for better orbital overlap. Boiling points. Carboxylic acids, alcohols. While both exhibit hydrogen bonding, carboxylic acids form stable dimers, effectively doubling the molecular size and increasing intermolecular strength. 2. IUPAC naming and classification. Naming strategy. 1. Find the longest chain including the functional group. 2. Number to give the functional group the lowest possible locant. 3. Alphabetize substituents, alcohol class, determined by how many carbons are attached to the COH carbon. 3. Methylbutane 2-ol is secondary, 2 carbons attached. 2. Methylpropane 2-ol is tertiary, 3 carbons attached. 3. Reaction summary. Oxidation. Primary alcohols, aldehydes, carboxylic acids, secondary, ketones, tertiary, no reaction. Esterification. A condensation reaction using concentrated sulfuric acid to combine an alcohol and carboxylic acid, spitting out water. Tests. Bromine water decolorizes for C equals C, NaHCO3 bubbles, CO2, 4COOH.4. Sustainability and math. Atom economy. A theoretical measure of waste prevention, percentage yield, a measure of experimental efficiency. Green chemistry prioritizes prevention of waste, using renewable feedstocks, industrial waste, and designing chemicals that degrade. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.